chapter 11 as we look at the concept of learning. And actually, for the next couple of chapters, we're going to be looking at learning, motor skill acquisition, and different aspects to it. In chapter 11, we're going to define what is learning and how do we measure learning. And the very first concept to grasp is that we really can't measure learning. We can only see performance and make inferences by what we see during practices and tests. So let's make that distinction between performance and learning. When we talk about performance, we're talking about executing a skill at a specific time, at a specific place. It's behavior that's observable. That's the performance. Whereas learning is not directly observable. We can only infer that a person has learned a motor skill by what we see. So our definition of learning would be a change in the ability to perform a skill that has to be inferred as we see relatively improvement over time as a result of practice or experience. Some general characteristics of learning. We would say we see improvement. If we see improvement, we can infer learning's taken place. Performance of a skill shows improvement over time. And we could say learning has occurred. When there's consistency, the performance becomes more similar over time rather than having a lot of variability. It's a stable performance. In other words, that disturbances to the performance is reduced and the performance is more stable regardless of any kind of disturbances that might occur. Also, persistence. And that's the idea that the improvement is seen consistently over time. And so we see an increasing level of performance that improves over the long haul. And then adaptability, where we actually see the performance being able to be adapted to a variety of settings, a variety of different contexts. And for adaptability, you can check your textbook for some other examples there. So as I make these inferences by watching performance to see if in fact skill learning has occurred, I'm looking for improvement of the skill, consistency of the skill, stability of the skill, persistence of the skill, and the adaptability of the skill. As I observe those characteristics, then I can make the inference from the performance that there has been skill acquisition acquired. Another characteristic of whether skill has been learned or not is just the reduce of attention demands. And we talked about attention in chapter 9, but we know that as a performer becomes more proficient, they're going to require less attention. And the example there, riding a bike, you can remember when you first learned how to ride a bike and how you were attending to lots of different things. And as you got better, you realize what was important to attend to, what wasn't. And up till now, where if you jump on a bike, relatively it's a ingrained, almost automatic motor skill that you have learned. So you have reduced attention demands. So as we look at the next section of the chapter, we're going to look at how do we assess learning. Again, as we infer learning from what we observe, there's some ways that we can measure learning. And so let's go through these. I probably won't get through them all in this lecture, but let's try to get through the first 2 or 3 at least. When we talk about performance curves, one way we can assess learning is by just plotting performance curves, which is a line graph that describes over time our performance. And so here you can see here at the bottom different types of performance curves, but along the horizontal axis would be time or number of trials, And along the vertical or the y-axis would be the actual performance measure that you're doing. So we can observe practice and assess learning by plotting these performance curves. And two things we're going to see pretty quickly will be, is improvement happening? And another characteristic would be, is there consistency? There's 4 different types or trends, these performance curves. We'll look at each one. One's linear, one's negatively accelerated, another one is called positively accelerated, and an S-shaped curve. So let's look at these. As we look at the linear curve, this is the idea that over time, you see improvement proportionally to the time that you put in. So the idea here is the more time I put in, the more improvement I'm going to see in my performance. And while that would be great, realistically, we know that's probably not the case. If not, then we all could become Olympic level athletes for just putting more time in. So that's a linear curve. The negatively accelerated curve shows that early improvement, but then as more time or trials go on, that improvement levels off. So that's called a negatively accelerated curve. And often this is what you see when someone is first learning a skill, because they have no background in the skill. You'll see a very quick spike improvement, but then there'll be a period of time where they begin to level off. That's called a negatively accelerated curve. The positively accelerated curve is just the opposite, where you go over a period of time with very little improvement, and then suddenly you see a spike up. When you're working with individuals that are on this type of performance curve, it could be very easy early on for them to get discouraged, to want to give up. And so the coach or the therapist during this time has to be a very good motivator of sticking to it and encouraging them with the idea that you are going to see improvement. You just have to stick with it. And again, we see this occasionally with perhaps someone in a rehab setting who just is not getting better, even though they're putting time in. Or sometimes in the area of sports, we might call these individuals late bloomers. Early on, they don't look like they're going to be very successful in a sport, and then suddenly they blossom. So that's the positively accelerated curve. The S-shaped curve is a combination where you have improvement and then you have a leveling off, and then you would have improvement again and a leveling off, and improvement again and leveling off. And then I always like to throw in my last slide, which I think illustrates what often happens when we're learning a skill. The idea early on, we're going to have a lot of variations, a lot of variety. But as I continue to improve and the line is going up, those wide variations become less. And again, I am improving and I'm seeing more consistent performance over time. So I call that the typical performance curve. Just make sure you are familiar with the 4 different types of performance curves and how they relate to learning motor skills. When we're measuring kinematic movements, and remember, kinematic displacement, like movement over time, over space, there's ways that we can measure if learning has occurred. Figure 11.1 in your textbook looks like this, and the actual criterion task is in a motor learning setting, and this is the movement I want to replicate. And so you can see the dotted line will be the standard deviation, and the solid line would be the criterion movement. So in the very beginning, you can see that the criterion movement is very different than what these illustrate. But this will be the mean. And then your standard deviation is quite wide, which means there's a lot of variability with this movement at the very beginning. But as we progress and practice, now the mean movement is becoming more or similar to their criterion task. And you can see the standard deviation is becoming less. And then as you get down to the very last block, we could say that learning has occurred because now the criterion mean is very similar to the task. So the mean that we have is very close to their criterion movement, and the standard deviation very small. So we could make the inference that learning has occurred with this kinematic movement task. So I think that's a good place to stop. When we come back, we'll finish up how we can measure different types of skill acquisition to see if learning has occurred.